Hello, and welcome to a little video about Target 1B, which talks about sequences. Sequences are patterns that involve the arrangement of numbers, shapes, letters, etc. Let's take a look. The first problem we have here are these dots. Hopefully, after taking a look and analyzing those dots, you see that they decrease by 4 dots. And those 4 are being chopped off the arms there. This is how the next 3 figures will look like. Let's represent them as numeric values. Oh, what did I do? I don't know. I wonder if the screen changed for you too. Anyways, so what we have here is the first figure has 25 dots. Oh no, it gave me such a small font. Well, let's make it 20-something. Let's make it 22. I'm just going to copy that so I can reuse it each time. All right, so the first image had 25 dots. The second has 21. The third has, so 4 less, that would be 17, 13, 9, 5, and 1. Just control copy that all. All right, we're going to take those numbers and we're going to put them into a table. Boop. Oh, well, that surely did not work. Ah, success. Let's drag this bad boy over here. All right, so the first term had 25 dots. Let's see if I can line it up beautifully. Oh, success. The second had 21. The third had 17. The fourth had 13 dots. The fifth had 9 dots. The sixth had 5 dots. And the 7 had 1 dot. Next we have a family tree. Here we have Jessica, who's investigating her family tree by researching each generation or set of parents. She learns all that she can about the first 4 generations. Let's count the parents in each generation. In the first generation, there are 2 parents. In the second, my bad, there's 4 parents because each of the parents had parents. The third generation has 8 because each of those parents had parents. And of course, the fourth generation, each of those parents had parents, there's 16. Hopefully, you can tell that what's going on here is the generations double. Yeah, the generations double. There's always twice as many. All right, so let's write the 5th and 6th generation. Well, if the 4th generation, whoops, there it goes again. If the 4th generation we had 16, then the 5th should have 32, the 6th should have 64. So just multiplying by 2. And now let's fill it in. Let's fill in the table. The first generation had 2 parents. The second had 4. The third had 8. The fourth had 16. The fifth had 32 parents in it. And the 6th has 64. Now, some of us are very lucky to have met our great-grandparents, but not all of us, which is unlucky. I've only gotten to meet one, and it was my great-grandma, and I'm really glad I had that chance. The next pattern we have is a collection of squares. Take a look at those squares and see if you see a pattern. Hopefully, by looking at it, you can see that they decrease by a row and column. This first square is a 7 by 7. The second one is a 6 by 6, 5 by 5, 4 by 4. So here are the next 2 figures, a 3 by 3, 2 by 2, and I know it's silly, but 1 by 1. Let's fill out the terms. My first shape, well, this is my first shape, the giant square. In it, it has 49 tiny squares. My second shape, 6 by 6, has 36 tiny squares. My third one has, 5 by 5, 25. My fourth one, 4 by 4 is 16. Interesting coincidence. My fifth one has 3 by 3, that's 9. My sixth shape has 4. And my seventh, my last shape, has just 1. Onwards we go. Ooh, Al's omelets, yum! Al is beginning each day with 150 eggs to make his famous Western omelets. After making 1 omelet, he has 144 eggs left. After 2, 138, and after 3, 132. So, what is the pattern? Hopefully you can see that the pattern is we decrease by 6 eggs each time. So what's the next 2 omelets going to be? Well, if you left off on 132, my next omelet, so I subtract 6, that's 126, and the omelet after that, I'll have 120 eggs left. Let's fill on the table. After my first one, we had 144. After my second, we have 138. After my third, we have 132. As we just found out, after the fourth, we have 126. And after the fifth, 120. Next, we have Donna's daisies. She is making a pattern on her bedroom walls using these decals. Check out and see if you have a specific pattern in mind there. Do you see what pattern's happening? Hopefully you can see that we have a repeating pattern. 3, 4, 2. So if we draw in the next 2 rows, they will, oh, I thought I had them drawn in. Let's draw in those next rows. The next row will have 3 daisies. I cannot draw these daisies on a computer. Won't even try. And 4. Okay. So my first row, or my first column had 3. Second has 4. The third has 2. And again, 3, 4, 2. 3, 4. So I'm just gonna fill it out like this. Onwards. Oh, all right, check out these triangles. Do you see the pattern? Hopefully you can see that, first of all, it's increasing, or it's getting larger. Increasing. The second has 2 more than the first. The third has 3 more than the second, etc., etc. So the fourth one has 4 more, and I'm not even going to try drawing this because I cannot. This is how it will look like. Let's do our table. My first pyramid has 1 triangle. My second one has 3. My third, add 3 to that, 6. My fourth, add 4 to that, 10. My fifth, add 5 to that, 15. My sixth, add 6, 21. Onwards we go. Micah is trying to beat his high score at his favorite video game. He begins with 500 points. Then after 1 mini game, he has 550. After 2, 600. After 3, 650. So, what's the pattern? Well, increasing each time by 50 points. So what will his score be in the next 2 games? Well, if after his third minigame he had 650. After his fourth one, he should have 700. And after his fifth, 750. Let's fill in the table. After one game, he has 550. After two, 600. 3, 650. 4, 700. Ooh. And after 5, 750. And onwards we go. Oh no. Oh, I hate when that happens. It just scrolled me all the way up. You see that? Ah, shame. All right, so we finished number 7. Beautiful. Okay, polygons. What do you notice about these polygons? Hopefully you notice that they increase by one side. And here are the next two figures. My first polygon was a triangle, 3 sides. My second one was a square, 4 sides. My third one is a pentagon, 5 sides. My fourth one is a hexagon, 6 sides. Septagon, I believe, has 7 sides. I don't know where I wrote the 7 there. That should be a 5. And my sixth shape is an octagon, has 8 sides. All right, almost there. We got a pizza contest. Jacob is participating in a pizza making contest. Each contestant has to bake the largest, most delicious pizza. Jacob's pizza has a 6-foot diameter. Oh, so much pizza. After the contest, he plans to cut the pizza so he can pass the slices out to share. He begins with a whole pizza, then cuts it in half, then another half, and another half. So what pattern is happening here? Well, in this case, the pattern is next slice is half the size of the previous. So let's take a look. Okay, so if he has, compared to the whole after the next 2 cuts. Okay, so we first have 1. Well, actually, let's see. I think I can type this one out. Let's do that. Let's do that. Oh, no. There we go. All right, so he starts off with a whole pizza. Then he cuts it in half. Then I half it again. Then I half it again. And one more time. All right, let's make a table. First, I have a whole pizza. No, that's not how I wanted to start this. I think I meant to start it with, 1, 2, 3, 4, 5, 6. I meant to start it with, yeah, just so. First, he has a 1 pizza. Then he cuts his pizza in half. And then quarter. And then 16th. Oh, 16th, I meant an 1/8. I can count. And then a 16th, there we go. And then 1/32 of a pizza. Last one, coin collecting. Miranda's uncle collects rare coins. He recently purchased a rare coin for $5. He claims that the value of the coin will triple every year. So even though the coin is currently worth $5, next year it'll be worth 15, then 45, and then 135. So what's the pattern? You kind of gave it away, Miss or Mr. or whoever you are, word problem. We triple. Each year, the value triples. Okay, so we know that after 3 years, it's going to be 135. So after 4, 135 times 3 is going to be 1215. And after 5 years, okay, let's multiply that by 3. Oh, man. 1215 times 3 is 3,645. Oh, I wrote that in the wrong place. 3,645. That's a lot of money. All right, let's make a table. So after 1 year, it'll be worth 15. After 2, 45. After 3, 135. After 4, it will be 1, 2. What did I write down wrong? Oh, nothing. Okay, I thought I wrote something down wrong. After 5 years, 3,645. And let's see, after 6 years, oh my, I wish I had that coin, 21,870. If you have any questions, please feel free to reach out to me or to your teacher. Otherwise, have a wonderful rest of whatever day it is for you. Bye!